By doing this repeatedly over several sessions, over several weeks, they quickly went in the cooling group from a maximum of somewhere between 180 and 200 to 600 pull-ups in the equivalent amount of time, which is absolutely incredible. Today, you're going to hear about specific tools that you can use to improve endurance and strength by up to, I'm not making this up, 3 or 4 times your current capacity. Okay, so let's talk about physical performance. There are so many variables to physical performance. Some of them are what I would consider foundational. And if you were to disrupt those, you would perform less well, like getting a good night's sleep, things like being properly hydrated. There are supplements, there are drugs, there are different ways to breathe. There are so many tools related to mindset, visualization. There are machines and devices. It's just a vast space. What I believe to be one of the most powerful tools to improve physical performance and skill learning and recovery, and that's temperature. Believe it or not, temperature is the most powerful variable for improving physical performance and for recovery. It's even more important than sleep because temperature itself is going to dictate how well and when you sleep and the depth of your total recovery. There are 2 aspects to temperature, of course. There's heat and there's cold. We are mainly going to focus on cold as a way to buffer heat. Cold, I would argue, is even more powerful than heat as a tool. And I'm not just talking about putting ice packs on sore muscles or slightly sprained limbs and ankles and things of that sort. We're going to talk about cold from the standpoint of thermal physiology. This is a literature that's rich in scientific information where physiologists and neuroscientists figured out that there are different compartments in your body that heat and cool you differently, and that you can leverage those in order to double, and as I mentioned before, even triple or quadruple your work output, both strength, repetitions, and endurance. It's not just about performing well once. It's about being able to perform well and recover from that performance so that you do even better when you're not incorporating these tools. What is temperature? How does temperature impact the body and its ability to perform, including learn new skills? Heating up too much is just plain bad. It's not just bad for physical performance, it's bad for all tissue health. If your brain heats up too much, neurons start dying, and those neurons don't come back. And you don't want to lose neurons in the central nervous system. If you get too hot, that'll happen. It's called hyperthermia. You want to avoid hyperthermia. And you have many mechanisms that are built into you to avoid becoming hyperthermic. The other thing that happens when we get too warm is that we have in all of our cells what are called enzymes. Enzymes are proteins, and they have a particular structure, and their structure becomes modified when heat increases, and that's not good. So one of the reasons why the body and nature goes through so much effort to build in mechanisms to make sure that we don't become too warm is because when we get too warm, these enzymes don't function. Cells stop functioning. They stop being able to generate energy. They stop being able to digest things. You stop being able to think. And eventually, those cells start dying off entirely. We have much more flexibility in terms of getting cold. Now, you don't want to become hypothermic either. You can die from hypothermia just like you can die from hyperthermia. However, that you have a lot more range to be cold than you do to be too warm. The idea is to keep the body and brain in a particular range, but anytime we do anything, our body temperature can shift. Now, what are those things? Well, there are a huge category of them. When you get into cold water, you secrete adrenaline. On a hot day, if it's really hot, or in a very hot sauna, or in the hot desert, you will generate what are called heat shock proteins, which will set off other sets of cascades, metabolic cascades, biological cascades. But the simplest way to think about this process is that when we get cold, we tend to vasoconstrict. Our blood vessels tend to constrict, and we tend to push energy toward the core of our body to preserve our core organs. When we heat up, our blood vessels vasodilate. They expand a bit, and more blood flows to our periphery, and more blood can move throughout the body generally, and we will perspire. We will sweat so that it can be dumped. We are dumping heat. And now the most important thing to understand is that if you get too hot, not only do those enzymes stop working, but your ability to contract your muscles stops. ATP is involved in the process of generating muscle contractions. Doesn't matter if you're running a marathon, doesn't matter if you're doing a yoga class, doesn't matter if you're going for a 700-pound squat. The range of temperatures within which ATP can function and muscles can contract is very narrow. Somewhere around 39 or 40 degrees Celsius, it drops off and you will not be able to generate more contractions. That temperature can be generated locally really fast. If you can keep temperature in range, however, in a proper range, you will be able to do more work. You will be able to create greater output. You'll be able to lift more weight, more sets, more reps, and you'll be able to run further. So how do you dump heat in order to perform longer safely? Well, in order to understand that, you have to understand that the body has three main compartments for regulating temperature. And there's one compartment in particular that all of you have. And if you can understand how that works, you can do tremendous things for your performance and for your recovery. One is your core. We already talked about that. The other is your periphery, which are obviously your arms and your legs and your feet and your hands. But then there's a third component, which is there are three locations on your body that are far better at passing heat out of the body and bringing cool into the body, such that you can heat up or cool your body everywhere very quickly. Face, the palms of your hands, and the bottoms of your feet. What's special about those areas of your body, the arrangement of vasculature, of blood vessels, capillaries, and arteries that serve those regions is very different than it is elsewhere in your body. There's a rule in vascular biology that blood moves from arteries to capillaries and then to veins and then back to the heart. These three regions of your hands, your face, and the bottoms of your feet, we have what are called AVAs. AVAs are a very special pattern of vasculature. But AVAs are direct connections between the small arteries and the small veins. They bypass the capillaries to some extent. These AVAs allow more heat to leave the body more quickly and more cool to enter the body more quickly. In other words, you can heat up best at the face, the palms, and the bottoms of the feet, and you can cool down best at the face, the palms, and the bottoms of the feet than you can anywhere else on your body. And when I say heat up or cool down, I mean actually heat or cool the core and your brain. Okay? They were studying overheating in athletes and in military and in construction workers and trying to prevent it. And they did a bunch of experiments. What they essentially found was that cooling the palms, palmar cooling, allowed people, athletes and recreational athletes, to run much further, to lift more weight, and to do more sets and reps to a absolutely staggering degree. What they essentially did is they brought someone into their laboratory who could do 10 pull-ups on the first set, and they were able to get 10, rest 2 or 3 minutes, get another 10, rest 2 or 3 minutes. And if you've ever tried this, what you find is that you start dropping to 8, 7, 6, etc. Then they used a device. They had people hold on to what was essentially a cold tube. That cool from the cold tube passes into the hand, these so-called palmar regions, and then cools the core. And in theory, by lowering body temperature, would allow the person or the athlete to do more work. Actual data, the specific data showed that subjects could do, at least the subjects they worked with, on their first day with no cooling, about 100 pull-ups across the time frame that they had. Then they came back and did the cooling. They did it the very next day, and they found that they went to 180 pull-ups, which is incredible. It's a near doubling. And by doing this repeatedly over several sessions, over several weeks, they quickly went in the cooling group from a maximum of somewhere between 180 and 200, as I recall, I'm sort of estimating now, to 600 pull-ups in the equivalent amount of time, which is absolutely incredible. So how can you start to incorporate this? Well, first of all, I always get asked, how cold should the water be? Should it be ice water? Should it be very cold water? The answer is no. If you want to experience some of this effect without a device, you could do your maximum number of pull-ups, stop, and then you could actually put your hands into or on the surface of a sink that is presumably stopped up with cool water. So not ice water, not freezing cold, but cool water. Slightly cooler than body temperature before you started training would be a good place to start. You do that for 10 to 30 seconds. Then you could go back and do your next set. You would repeat the cooling. You would want to extend the amount of cooling somewhat. So you might want to do that for 30 seconds to a minute. This is not going to be perfect. You're going to have to play with how cold to make it in order to get the optimal effect. Same is true if you're running and you're fatiguing. Obviously, you don't want to become hyperthermic. Cooling the hands or the bottoms of your feet or the face would be the ideal way to dump heat in order to be able to generate more output. You could take a frozen juice can, if you have one of those, or a very cold can of soda, and you would want to pass it back and forth between your two hands. The reason the passing back and forth is really important is because you don't want to be so cold that you constrict those venous portals that will allow cold to go into the body. Once again, we've covered a lot of material. By now, you should understand a lot about how your body heats and cools itself and the value of that for physical performance. I hope you'll also appreciate that you have tools at your disposal to vastly improve your physical performance. And should you try those, please let us know how it goes. If you decide to do Palmer cooling during your runs or after your runs, during your weight workouts, during your yoga sessions, whatever it is, let us know. Please place that in the comments.